Hello and welcome to Intro to Expanding and Factorising. So, expanding and factorising are the opposites of each other. So when we're asked to expand the brackets, what it actually means is times out the brackets. So we have x plus 4, and that's times by x plus 3. Now there are a few ways of doing this. I like to think about it as a claw. Thus, we call it the claw method. Now what each of the lines do is show us what we are timesing by each other. Okay? So, we get x times x, and that's x squared. We get x times 4, plus 4x. We get 4 times 3, and we get 3 times x. So that is x squared plus 7x plus 12. Done. Other thing you need to realise is if I gave you x plus 2 squared, that means it's x plus 2 times x plus 2. Now a common mistake here is to just do x times x and 2 by 2, but again we have the claw. So that equals x squared plus 2x plus 4 plus 2x, and that equals x squared plus 4x plus 4. Okay. Next thing we're going to do is factorising. Now, as I said before, factorising is the opposite of expanding. So what we're trying to do is we're trying to take this x squared plus 3x plus 2 and put it into two brackets. Okay? X times x gives us x squared. So that goes there and there. Now, we have 2 here, so we know that that number times that number, whatever they are, is going to equal plus 2. So the factors of 2 are 1 and 2. Now actually, in the next step we're going to learn a more advanced trick. You're going to see that then 1 times 2 is 2, 1 plus 2 is 3. So when we have x times that, and that times x, we're going to have 1x and 2x. So it goes x plus 1, x plus 2. Now note, if all it has said here is to factorise this, that's all you do. We're not asking to solve it, which is when you get x equals. You're just asking to turn it into two factors. And that is what we have done here. So, that is for the simpler ones, where you've only got x squared. At the front, you haven't got a number. Next, we're going to look at what we do when we have got a number. So, we've got 6x squared plus 17x plus 5. Now, the trick for this one. Take your number in front of x, times it by this number on its own over here. 6 times 5 equals 30. Now, we're going to find all of the factors of 30. So that's 1, 30, 2, 15, 3 and 10, 4s don't go in, and 5 and 6. Now this was a positive 6 times a positive 5, so it goes a positive 30. The fact that it's positive means we're going to have this number here plus that number there, and it needs to make 17. So 30 plus 1, no. 15 plus 2, oh, that'll mux. And just to show you, none of the others actually work. 10 plus 3 is not 17. 5 plus 6 is not 17. So, we write it out again. The 6x squared hasn't changed. Instead of 17x, we write it as plus 2x plus 15x, and the plus 5 hasn't changed. Now, we could have written this out the other way around, with plus 15x plus 2, and it won't change our final answer. If you'd like to have a go at that after you've seen this example, I would suggest doing so. So now we take our first two terms, and what we're going to do is we're going to look at these terms completely separately. So 6x squared plus 2x. Right, and we're going to look at the next two terms completely separately. 15x plus 5. So I've added these brackets in. Okay, so I'm going to factorise out what have I got in here that both of them have. Well, they've both got an x and they've both got a power of 2. Cool. So I'm going to take 2x out of the brackets. What's left over? Well, 2x times 3x gives us 6x squared. 2x times 1 gives us 2x. Okay. Next one. Well, they've both got a 5. Okay. So we put in 5, which leaves us 3x plus 1. Now, at this point, this number, or this function, is going to be exactly the same as that. So they've both got that in it. We can take it out because they've both got a factor of 3x plus 1. Okay, how many 3x plus 1s have we got on the first bit? We got 2x of them. How many have we got in the second bit? We got plus 5 of them. And there you go. We have factorised this more complicated quadratic. Okay, now I'm going to show you how we do that with another one, but if you want to try doing this the other way around, now would be a good time to pause this video and have a go at it. So, I'm now going to have a go at 12x squared minus 5x minus 3. Exactly the same concept. I'm going to do 12 times minus 3, which gives me minus 36. Factors of 36. 1, 36, 2 and 18, 3 and 12, 4 and 9, 5s that go into it, 6 and 6. There we go, those are all the factors. Now, this one's a bit different because it's a minus 36. So, rather than adding these together to try and get this number, we're going to take them from each other. Okay? Now we want to get minus 5, so we're going to do the smaller minus the bigger. 1 minus 36. Nope. 2 minus 18. Nope. 3 minus 12. Nope. 4 minus 9. Oh look, 4 minus 9 is minus 5. And 6 minus 6 would be 0. So, we have that one. So again, I write my x squared bit exactly as it is. Then I've got plus 4x minus 9x. And the minus 3 is exactly the same. Now note, again, we could have written minus 9x plus 4x, and if you want to have a go at that in a moment, feel free. We're now going to break them up into the separate sections again. 12x squared plus 4x plus minus 9x minus 3. Okay, look at the first one. 4x goes into it, so we get 3x plus 1. The second one, 3 to go into it. Okay, 3 minus x minus 3x minus 1. Now, this and this don't look the same, and that's because we can take a minus 1 out of here, put it in front. So actually, it can be 4x, 3x plus 1, minus 3, 3x plus 1. Now, again, that and that are the same. So both of these have a factor of 3x plus 1. So 3x plus 1 comes out. We have 4x minus 3 of them. There we go. That's the other one done. Right, let's move on. Okay, dealing with negative numbers. Right, this sort of problem is actually solved in a very similar way to what we were just doing. So, we could go through and put a minus x and an x in, but it gets complicated and there's a much easier trick. all we do is bring a minus 1 to the outside. Okay, so this becomes 2x squared minus 5x minus 3. Right, next step, we always do that times that, so 2 times minus 3, which is minus 6, right, it's a minus, so we're going to take away 1 and 6, 2 and 3, we want to get minus 5, 1 minus 6. 2x squared plus 1 minus 6, that's 1x minus 6x minus 3. Separate them out. 2x squared plus x plus minus 6x minus 3. Take out common factors. 2x plus 1. We can now see that yet again we've got a common factor inside here. They've both got a 2x plus 1. So that equals, minus is still there, 2x plus 1, and we've got x minus 3. And there we go. That question's done. Now, it could be written as minus 2x minus 1 times x minus 3. That would be acceptable, although I would always have brought that minus sign out. Or it could have been written as 2x plus 1 minus x plus 3, or 3 minus x. Again, acceptable. I think this is a much nicer way of seeing it, though. There we go. Okay then. The difference of two squares. What we mean by the difference of two squares is something like this. Okay, bit of pattern recognition. If you ever see that, it's a square minus a square, the difference of two squares. You need to be able to know that that equals x plus a, x minus a. Okay, so, let's have a little look at that. Times it out. That would be x squared plus ax minus ax minus a squared. Plus ax minus ax, they cancel, and as expected, this equals x squared minus a squared. Now, this can look a bit different. I could give you 4y squared minus 9b squared. And that would equal 2y plus 3b, 2y minus 3b. Okay, and as I said, that's pattern recognition that will just come up inside of other problems, right? So watch out for that. So, quadratics with two variables. When approached in this way, this side of things, it's not too hard to see what we have to do. X plus a times 2x plus a. Okay, we draw our claw. That equals 2x squared plus 2xa plus xa plus a squared. That equals 2x squared plus 3xa plus a squared. Now, what I want to point out to you isn't so much going from this side to this side, it's going backwards. Quite often people get stuck when they look at this and they go, oh, what the hell is it? I can't see how to move around this. Okay, it's still a quadratic in x squared, but we've got an a squared here, and what you'll notice is you will have an x squared term, an x times whatever this thing a is term, and an a squared term. My suggestion for dealing with a problem like this is to think about it as if a was just 1 for a moment. You get 2x squared plus 3x plus 1, and if I just solve that, 2x squared plus 3x plus 1, we get 2x plus 1, x plus 1. Okay, that's easy enough. However, when it comes out to like this, we have the extra a, what you can see is this came for an a times a, and these had an extra a term in it. So what I'm trying to show you here is that when you've got a problem like this, where you've got an a squared as well as an x squared, it actually looks like that. Okay? Try solving it without the a squareds and then see how they plug in. Make your life a lot easier. The next thing I want to show you is how to use quadratics in context. So, when originally faced with a problem like this, it can feel very daunting. 96 squared without using calculator. Okay, I'll do 96 times 96. Wait. That's not quite what it's asking. Okay? 96 squared. Let's have a look at that. 96 squared. Well, that's the same as 100 minus 4 squared. Okay? Well, we can times that out. That's 100 squared minus 2 times 4 times 100 plus 4 squared. That's 10,000 minus 800 plus 16, which is 9,200 plus 16, which is 9,216. There we go. Not too bad. Another style of problem. I could give you a triangle, and I could say that this length here is 106. Oops, excuse me. 106. I can say that is 94, and that's x, and it's a right angle triangle, and I can say find x without using a calculator. This feels horrible. What we know is you have 106 squared equals 94 squared plus x squared. So x squared equals 106 squared minus 94 squared. Oh look, we have difference to squares. So x squared equals 106 plus 94 times 106 minus 94. Okay, that equals 200 times by 12. Okay, now this is still x squared, so I'm just going to have a look at this because I'm about to square root. I'm going to bring out my square numbers. So I have 100 times 2, that's 200, times 3 times 4. X squared equals that. So x equals, square rooting it, we will get 20 root 6. Now that is quite remarkable, that we can deal with a problem as tough as this, get an answer like that without needing a calculator. And it's all because when I wrote this out, I was able to see that it was forming a difference of two squares, brought it in by difference of two squares, and solved it. Okay? And that is where the power of this sort of maths comes in. Okay. Moving on to the last part of this video. Cancelling algebraic fractions. Okay. You get seen something like this, and it'll probably say simplify. Okay? So now you've got to work out what on earth do you do. Right, we got some x squareds in here. So the very first thing that you want to do is factorise them. x squared minus 2x minus 3. So we've got an x squared top and bottom, so we're going to factorise everything. X plus 1, x plus 2, that times that's the top one, and we're going to have x plus 1, x minus 3. Right? If you don't see that, spend a little bit of time and just practice again factorising these quadratics. This is why you want to practice them, because you want to be able to do this quite quickly. Now what we can see is both top and bottom have an x plus 1, and because it's everything on top times by x plus 1 and everything on bottom times by x plus 1, we can divide top and bottom by x plus 1. And that means this simplifies to x plus 2 over x minus 3. And now you're done. Now, a very common mistake here is to attempt to cancel these x's. You can't do that, okay? Because it's a plus in here. You can only cancel if everything is times by it, like in this situation. Everything is not times by x top and bottom here. So that would be how you'd leave your answer. Now this sort of question is going to bring in lots of things. You might have a difference of two squares in there. You might have anything else that we've been playing with inside this sort of problem. Okay? I hope that all made sense to you.